Hi everyone, welcome to my channel CSlog by Soubhagya. Recently I was going through DSA and doing some revision. So I covered the sorting part of DSA. So I thought why not to share with you all of you in my channel. So I have covered all the sorting algorithms, but I'll make this in this video. I'll make you go through three sorting algorithm. That is, first is selection sort, and second one is the bubble sort, and the third one is the insertion sort. So maybe you all know these sorting algorithms. It will work as a quick recap or revision for you as well. Otherwise, if you don't know, also it can help you to learn these things. So I prefer to make these videos in easy language so that you can all learn these things. So let's get into this sorting algorithms. So there will be also the second part of this video. I'll be sharing the merge sort and queue sort, and whatever sorting algorithm we will learn like bubble sort or insertion sort, we'll also see how we can sort them using recursion. So in the second part it will come, but in this part we'll see these three sorting algorithms. Let's jump into it. So let's start with this selection sort. So in selection sort, what we do, we first try to traverse the array, and for each pair we try to find the minimum. So let's say we are trying to get the first element, and for the first element, what is the minimum, and we do the comparison and we swap it. So there are one task we need to do. First is the find the minimum, and second one is swapping the items, and we have to repeat this task until the array is not over. So I have an array which is having the total 7 elements, and the array names ARR, and let's do one dry run and see how this algorithm works. So in step 1 we need to pick the first element, that is 8, and that will be by default our minimum value, and we traverse the whole array and we will find which one is the minimum with respect to 8. Okay, so first we will do the comparison of 8 and 10, and minimum will be 8 because 8 is the minimum one. Then we will do 8 and 2. Here the minimum value will be get changed, that is 2. Then we will do 2 and 9, and the minimum value will be remain as 2. Then we will do 2 6, the 2 will be the minimum, and then 2 11, again 2 will be the minimum, then 2 16, again the 2 will be the minimum. So basically what we are doing now, so we will do this 8 and 2 and we will swap it. So after this the array will be looking like this. So 2 will be become first, then 10, then 8, and then 9, 6, 11, 16. So all the elements will remain as it is. Then we will go to the second element, that is 10. So in the next step, that will be step 2, or you can say the round 2, the next iteration. So we'll pick the minimum value, that is 10 will be by default because this is the first one. We'll do the comparison 10 and 8, and we got that 8 is the minimum, so the value will be updated. Then 8 and 9, the value will be 8, or the minimum value. Then 8 and 6, the minimum value will be 6. Then 6 and 11, the minimum value will be 6. Then 6 and 16, the minimum value will be 6. So basically 10 and 6, so these value will be got swapped. So now the array will be looking like this, where 2 will be there, then 6 will be there, then 8 will be there, then 9 will be there, then here 10 will be there, then 11 will be there, then 16 will be there. Then we'll go to the next element, that is the third element, that is 8. So you can see whenever we are finding the minimum value and we are replacing, means we are swapping, you can see the left side of this array is getting sorted. Okay, so it is mean that whenever the first iteration value we are getting, before that values are getting sorted. So we are sorting the array from the left side itself. So then the third step we'll see in step 3. So the 8, that will be the minimum, and we'll do the comparison of 8 9, there will be no change. Then 8 and 10, there will be no change. Then 8 11, there will be no change. Then there will be 8 and 16, there will be no change. So this 8 will not be swapped with anyone. As you can see, the right side of this array will be remain as it is, because the 8 items are already sorted, okay, from the very beginning. Okay, so next time there will be no change. Then in step 4 you will be picking up this 9 1, then you will do 9 10 comparison, 9 11 comparison, 9 16 comparison, there will be no change. Then step 5 you will take, then 10 11 comparison will do, there will be no change. 10 16 comparison will do, there will be no change. Then in step 6 you will pick the 11 and 16 comparison will do, there will be no change. And do you need step 7? Do you need to pick this 16 element, means the last element? Don't need that, because the last element is already sorted, and whenever you are taking only one element, that is already sorted. Okay, so we don't need to do that. So this is how the selection sort algorithm works. So let me rewrite the pseudocode for you. So it will be for I equal to 0, I less than n minus 1. Okay, then I plus plus, because we are giving up the last element. Inside that we are taking the minimum value equal to array of I. Okay, or you can say if we don't have to keep the value, what we'll do, we'll only keep the element, so maybe it will be better. So minimum, let's say that we are keeping the index value. Then we'll do for j equal to, from j it will start from I right, I plus 1, so equal to I plus 1, then j less than n, then j plus plus. Okay, so we'll do the comparison arr of j if less than arr of mean, right? What it will do, will keep mean equal to j, right? So in this way it will go, and after this, once it will be we will find the minimum element or minimum index. After this for loop, we will do the swap of arr of I and arr of mean. Okay, then this for loop will end. So this is the pseudo code for this, and we'll try to do so we'll try to do this coding in Python. In any language you can also do that. Anyway, I have written this code for C, Java as well, so I'll try to do in Python. The time complexity of best case, average, and worst case as well. So now let's go to the coding part, and we'll see how to code this. So we'll start the coding of selection sort. So as you can see, we are having one function which is having no body, and there is one array which is having some elements starting from 10 to 345, is in not an order. We will try to sort it, and we are passing that array to that function selection sort, and we'll start the setup or whatever we have discussed before. We'll try to code it. So we'll write the first for loop. So it will be for I in range. We'll go till the last before element. So I would say length of array -1, and we'll first keep the first index, means that index of that element in the min index. Then we'll write the second for loop for I in range, and it will start from I till the length of array. Then we'll do one comparison. If array of j is less than array of mini, then we'll update the mini value, which will be j, and once the minimum value will find it, we'll do swap. So in Python it is very beautiful that how we can swap it. Basically it is a one-liner. So array of I and array of mini, means mean index, equal to array of mean index and array of I. So without any temporary variable, we can swap it in this way. And after this we are just returning that array. So I guess it is fine. Let's execute this. So you can see the array has been sorted. 3 is the most minimum, and means smallest, and 345 is the largest, and it is ordered in an increasing way. So yeah, this is selection sort. Let's jump into the next sorting algorithm, that is the bubble sort. Hi everyone, let's start the bubble sort. So in this bubble sort, what we need to do, it is the opposite of our selection sort. So in this one we have to first find the maximum by checking the adjacent elements, and once we will find that one, then we swap between those elements, so that we will keep the maximum value at the end of the array. Keep maximum at end of array. So let's do one round of dry run so that we will understand how does it work. So in step 1, you can see first we'll do the comparison of 11 and 13. So 13 is the maximum, so we don't need to do anything. And then we do 13 and 2. So basically we are going in this way, then 2 8, then 8 16, then 16 and 4. In this way we'll go. So 13 and 2, so 13 is the maximum. So what we'll do, we'll just do this swapping thing. Okay, so the new array will be looking like this: 11 2 13 8 16 and 14. Then we'll do 2 and 8. 8 is the 13 and 8. Okay, so 13 is the maximum. Then we will do the swap. So 11 2 8 13 16 and 14. Then for 13 and 16 we'll do the comparison. So there will be no change because 16 is the maximum, means the largest one. then we'll do 16 and 14. So 16 is the larger one, so it will be got swapped. So 11, 2, 8, 13, 14 and 16. So you can see 16 is the maximum among this array, and we are able to keep the maximum at the end of the array. So now the final array will be looking like this: 2, 8, 13, 14 and 16, and we will skip the right part and we will start working on these part of this array. So in step 2, so again we will do the comparison of 11 2. So 11 is the largest one, so it will be got swapped. So it will be 2, 11, then 8, 13, 14 and 16 as it is. Then we will do this comparison 11 and 8. So there will be swap because 11 is the larger one. So it will be 2, 8, 11, then 13, then 14, then 16, right? So then we'll do the 11 13 comparison. There will be no change. Then 13 and 14 there will be no change. Then 14 and 16 there will be no change. So you can see 14 and 16 as already sorted. The new array will be 2, 8, 11, 13, 14 and 16. So we'll do the comparison of 2 and 8. 8 is the largest one, there will be no change. Then 8 and 11, 11 the largest change, there is no change. Then 11 and 13, 13 is the largest one, there will be no change. 13 and 14, 14 is the largest one, there will no change. Sorry, we will not go to the 14, my mistake. Okay. So this one is already sorted. So you can see this part is already sorted. So even if you will do the comparison, it will till this one will do, then this one will do, then this one will do. So it is already sorted. Okay. So the pseudocode will be for this. So you will go for I equal to 0 to I less than n, then I plus plus, and do the for second loop for j equal to 0, j less than equal to n minus I minus 1, then j plus plus. And here if array of j is greater than array of j plus 1, so we are doing the comparison of two adjacent one, so then we are doing the swapping things and then we are returning the array. So the major question is why I have taken this one. Okay, so if we'll see n minus I minus 1, so if I equal to 0, then it will be total 6 elements, then 0 minus 1, it will be 5. Then if I equal to 1, then it will be 6 minus 1 minus 1, it will be 4. So like this it will be 2, like this 3, 2, 1, it will decrease by 1 by 1. So first we are omitting this one, then we are omitting this one, then we are omitting this one, then we are omitting this one. So in this way, to decrease the size of the array, we are restricting ourselves to do the comparison till n minus I minus 1. Okay, so let's see the coding part of it. Let's start how to do the code in the Python. So here you can see there is one array which is having the same element which we have taken for the selection sort, and we are passing that array to the bubble sort function, which is having no definition of or body, you can say. So first we'll write the first for loop, which will range from 0th element to the length of array. By default the range function starts from 0, so we don't have to mention it. So the next for loop will start from 0 to the length of array minus I minus 1, and we'll do the checking between the adjacent array. So it will be if ARR of j is greater than array of j plus 1. Then we need to swap it, so it will be j arr of j plus 1 equal to arr of j plus 1 arr of j. So once we are swapping it, then we have to return the array. Let's execute this. You can see the array has been sorted, and we completed the coding of bubble sort. Let's see the next sorting algorithm, that is insertion sort. In insertion sort, what we'll first do, we'll take one element from 0th index till the last index, and whatever the place it should go, it will just go before that. So let's say the first element is 7, and it will keep in the array as it is. Then if it is 17, then it will go right side of this 7. If it is 3, it will go the left side of this 3, and if it is 1, then it will go at the beginning of 1. So basically we are inserting the element where it must go on. If it is 0, then it is go there. Then if it is 11, between 7 and 17, it will go 11 over there. If it is 14, then between 11 and 17, it will go 14. So it will 0 1 3 7 11 14 17. So this is the insertion sort algorithm does, but basically how it works. So if we'll see in the step 1, so first we are having 7, then next if it is 17, so 17 is the larger one and 7 is the smaller one, so there will be no change. But when it is 3, so if it is smaller than the previous one, then we will do the swap thing. So it will be 7, then 3, then 17. Then if 3, again the comparison of 7, it is the smaller one, then the swap will happen. So 3, 7 and 17. So by taking these 3 elements, we got 3, 7, 17. Then 1 will come, again 1 is small, then the means the swapping will happen. So 3, 7, 1, 17 will happen. Then 1 is again small, so swapping will happen. So 3, 1, 7, 17 is there. Then 1 will swap it, so 1, 3, 7, 17. So in this way, the whole array will process, and the pseudocode of it will be, so for I equal to 0, I less than n, I plus plus, for j equal to I till j less than equal to 0, then j minus minus. Then we are doing the comparison. If arr of j is greater than or j minus or sorry small less than arr of j, then we are swapping it. So this is the pseudocode. So let's start the coding part of it. And the time complexity in the worst case, it will be order of n square, and in best case, if it is already sorted, the time complexity will be order of n. We'll see the coding part. So let's see the coding part of it, where the same array we have taken, which we have been taken previously for those two sorting algorithm, and the same array has been passed to the insertion sort function. So let's write the first code, means first for loop, for I in range, and it will go till the length of array, and for j in range, it will go from backward from ith element to the 0th element. From I, then it will be 0, then it will be minus 1. Then if arr of j is smaller than arr of j minus 1, Then we are doing the swapping thing. A j minus 1 of j. Then we are returning the array. So this is the code. Let's execute it. So see, we got the same sorted array, and with this we are ending the sorting of 3 sorting algorithm, that is insertion sort, bubble sort, and selection sort. In the next part we'll see the merge sort and queue sort, and we'll also see how this selection sort and bubble sort we can do using the recursion. Thank you.